Well, hello and welcome to Chapter 10. Chapter 10, we are going to talk about how to access files, how to read files, how to write to files, how to um, basically write to records, fields within records, and basically how to find the end of file and how to use delimiters between the different fields that are within each record. And then we will talk about this thing called control break processing. Okay, we'll also get into a little bit of arrays here, how we can get an array and then basically load that into a file. So let's get started. Okay, so first thing the chapter talks about is introduction to file input and output. Basically, it says when a program needs to save data for later use, it writes the data to a file. The data can be read from the file and then basically read at a later time. Now, one thing this particular chapter is not going to get into is this thing called databases. Now, databases are kind of a separate beast altogether. In fact, databases kind of have their own programming language, something called SQL, Sequential Query Language. We will get into that into the 255 class, but in this particular chapter we will not. So anyways, most of the commercial software packages that we basically utilize today, like different word processors and image editors and spreadsheets and games and different types of web browsers, all basically have to deal with data. How do we get data from something like a game? As you get high scores, we have to basically write those high scores somewhere and then sort them and process them in a way to display who's got the highest score. So there's a whole lot of different places to store data and edit data and basically get to the data, reading, writing, whatever the case may be. So here the example they show is we have a disk, a hard drive, and we need to store the pay rate, the employee ID, and the employee name. Okay, so notice the arrows are going to the disk. We come down here, well, now we need to read that data at a later time, and so now we're reading those. Now this is called a record. So this is a record, and that record has three fields. It has pay rate, employee ID, and employee name. So those are read. So this record is read from the file, and then we can basically whatever we need to do to process it. Okay, maybe there is an hourly our hours worked field that we will get from another file that has the employee ID. We read that and then we basically multiply the hours times the pay rate to get to the gross pay. And we might have another program that then figures out federal income tax and state income tax and FICA and all those different Medicare, all those different taxable items that are basically there. So basically, up down here what we do, we'd open it. So here's the process we have to do first. The very first thing you have to do is you have to open a file. Now, some programming languages you have to open that file for read, or you have to open that file for write. Whatever the case may be, you have to basically open that file. Okay? Then you process that file, whether you read it, whether you write it, whatever the case may be, and when you're done, you have to close it. Okay, so you have to close that particular file. Now, in some languages, when the program ends, if the file's not closed, it will do it for you. Some languages won't do that, and we can have problems with that. So again, make sure that's basically required. You have to close a file when you are done. Now, there's different ways to access files. We can have what are called delimiters. You hear the term comma delimited file. That means that each row within the file is a record, and then within the record you've got commas that separate each field, or it could be tabs, or it could be dashes, whatever the delimiter that your program is using as a delimiter, that's basically what we'll take and split those fields up. We also have what are called dynamic files. What do I mean by that? Well, we may get this into another chapter, but I want you to think of a cassette tape if you're old enough to remember a cassette tape. But a cassette tape, when we listen to a cassette tape, with music, if I wanted to listen to song number 3, I had to basically start at the beginning of the tape and fast forward till I got to song number 3, and basically, so the computer, not so much the tape player, but the computer has to read those first couple of records to get to that third record, that third song. Where CDs today, I can actually say, I want you to play song number 3. I hit that button and it will play song number 3. Now, that's what are called dynamic records. Now, the thing about dynamic records, and this has nothing to do with CDs, but dynamic records is each record is the same exact length. So if each record is 100 bytes long, I know that at 101 bytes, record number 2 starts. I know at 201 is where record number 3 starts. I'm sorry, record number 2 starts. 301 is where record number 3 starts, so on and so forth. And then each field is the same length. So I can actually say, go to record number 4. It will go to the 401 spot, start right there, and read a 100-byte section. Okay, those are dynamic. So I can then take a record and replace it. I can delete it. So there's all kinds of different things we can do. And again, we're not going to cover that in this particular chapter, but just I want you to keep that kind of in the back of your mind as we go forward and we start basically getting into different types of file types, especially when we get into the advanced classes. Okay, so most computer users are accustomed to the fact that files are written by file name, for example. So again, we've got a file name and we got a .3 extension that we basically utilize behind that. In this case, JPG is a JPEG, TXT is a text file, and a DOC is a Word document. So, so the very first thing we have to do, just like anything, we have to declare a file. Okay, and so in this particular case, I'm going to say declare output file, customer file. Now notice I'm saying output file. That means I'm only going to be able to write to this file. I cannot read from this file. If I want to read from it, we'll see that here in a little bit, what we have to do. So the word output file contains the mode in which we will use in our pseudocode. So our pseudocode or our flowchart, we are going to say declare output file and then the file name. And then the next step, again, just like I talked about earlier, we have to open that file. So I will say open customer file, and then in parentheses, I will put the actual file name. In this case, customers.dat. Okay, it says warning, remember when you open an output file, you're creating that file on the disk. In most languages, if a file with the specified external name already exists, when this file is open, the contents of the existing file will be erased. Basically, it will overwrite that file. So we'll see later on in this chapter how we can basically get around that, but realize that when you open a file, if it's not already there, it's created new. If it's already there and we open it for output, it just completely wipes it out. Okay, so basically keep that in the back of your mind as well. So writing data to a file, I will say write customer file, and then basically in this case I'm actually writing a string literal Charles Pace. So that is going to be the entire record. It's just that one particular piece of data. Or I could say declare string name Charles Pace and then say write customer file name. That is the preferred way to do that. We rarely ever use string literals to basically write files or basically, like last chapter we talked about arrays. We do not basically make the size a numeric literal. We actually would use that as a variable. Okay, so then when we get done, we just say close customer file. That's it. Okay. So this is what it would look like in a flowchart. We start, we declare our output file, my file. We open my file, philosophers.dat. We write my file, John Locke. Write my file, David Hume. Write my file, Edmund Burke. Then we close my file and we're end. That's it. Okay. Now, I want you to think about each record being written to as one line. Okay, so it wrote John Locke. Drop down a line, it wrote David Hume. Drop down a line, and it wrote Edmund Burke. Okay, so each one of those is on a separate line. This would look like in pseudocode: declare output file my file, open my file philosophers.dat. Notice we've got the double quotes around that because that is a file literal name that we're telling it that's where I want you to open it. I would actually put in front of the philosophers, a P in philosophers, I would put C:/ users / marks / and then wherever, so the path of where that file is basically located. If it's located on a network drive, you would basically put that in front of it as well. If this is assuming that wherever the program resides, this is where the file resides as well. So just kind of keep that also in the back of your mind as we go forward and we get into the different higher level classes. Okay, like CIS 155 and 255. Okay, we write my file John Locke, write my file David Hume, write my file Edmund Burke, and then we close the file. It's as simple as that. So this is what the file would look like. We have our beginning of file, we have our end of file, and then we have the different records. Each one of those is considered a record. It's not a field, it's a record. Now, the one thing that files have that we can't see when we open it are what is called the beginning of file marker and the end of file marker. The end of file is what we call the EOF. The EOF basically tells us where the file ends. And we can actually program to look for that. Okay, so here we've got John Locke, a delimiter. Now that delimiter is in a regular text file is the carriage return. It tells it to go to the next line. That's the delimiter. So we've got John Locke, our delimiter, go to the next line. David Hume, delimiter, go to the next line. Edmund Burke, delimiter, go to the next line. And then there's no more records, so there's an end of file mark there that basically tells where the file ends. Okay, so we talked about writing to a file. Now we want to read that file. So I declare input file, inventory file. So now I've told it that this file is only going to be read for input. It's not, we won't be able to write to this file, we can only read from it. So I've declared the file, then I say open inventory file, double quote, inventory.dat, double quote. So now I've got the file opened. Now that it's open, I can now read it. And I would just say read inventory file item name. So item name is going to be a variable. Now we would have to already basically have that declared, but that is a variable that we're going to read that record into. And then again, once we're done, we say close inventory file. So here I have my start. I have my declare input file, my file. I declare string name 1, name 2, name 3. So now I have 3 variables. They're all string data type. I then say open my file philosophers.dat. So the file's now open. I can now read it. So I say read my file name 1. Read my file. So the next time I do a read, so the first time I do a read, I've read a record. And so kind of here's what happens. So it read that first line of text and it automatically drops down to the next line and it's waiting. Okay? I process that record, and when I say read again, it's already sitting at that next line, and it reads that guy and automatically drops down to the next line. Okay, so that's basically what's going on here. So when I say read my file, it read that first line of which is a record, and put that into name 1. Next time I do a read, it's already at the next line, so it read the next line of text, and it put that into name 2. So it's a drop down to the next line. When I say read my file, it read the next line and put that into the variable name 3. Then I close my file and I display, here are the names of the 3 philosophers. Display name 1, display name 2, display name 3. Now, could there have been more names or more records in that file? There could have been. We just read the first 3. Could have been the only 3. Now, what would happen if there had been 2 names in there and I tried to read a third name? Again, I would have got an error and the program would have basically blown up because it says, I hit the end of file marker. I don't know where that third record is. Pseudocode, again, declare string name 1, name 2, name 3. Open my file. Declare. I forgot to read the declare my file. So declare input file my file. Then I open my file, double quote, philosophers.dat. Read my file name 1, read my file name 2, read my file name 3, close my file. Then I say display, here are the names of the 3 philosophers, display name 1, display name 2, display name 3. So if we took this pseudocode in conjunction with the previous section pseudocode, we can see where we wrote to those 3 names and then would basically print them out. So here are the names of the 3 philosophers, John Locke, David Hume, and Edmund Burke. Okay. So again, this is kind of what I was talking about. So when I read the first record, it read till it hit the delimiter. And again, the pointer is now sitting right here at the next record. And when it reads that one, it basically gets past the delimiter and it's now sitting there for the 3rd time. So basically that is what is going on there. So if I open a file for output, if the file doesn't exist, it's created new. If it does exist, it's wiped out. But what if I don't want to delete that file? I want to add stuff to it. Well, I can open that file in append mode. So I would say declare output file, append mode, my file. So now what I've told it is if the file exists, go to the end of file marker, place your pointer there, and that's where you're going to start writing. This is at the very end. If the file doesn't exist, it's going to create it as a brand new file. Okay, so if this record already has Joe, Rose, Greg, Gary, and Renee, well, I can now say open my file. So I've declared output file, append mode my file, open my file, friends.dat, write my file Matt, Chris, and Susie. And now if I were to read that file, it would say Joe, Rose, Greg, Jerry, Renee, Matt, Chris, and Susie. So now I can append to a file. So if I open it for output, just open it for output, it's going to overwrite whatever's there. If I open it for output append mode, it will not erase what's there and allow me to add to the very end of that file. Okay, so this next section, so as we saw a second ago, I can basically read 1, 2, 3, I can write 1, 2, 3, but what if I have, I know, every time I run this program, I don't know how many records are going to be there. Well, again, we can use a looping process to basically do this. So, let's take a look at this video.
Hello, this is Tony Gaddis. In this video, I'm going to discuss how loops are used in the process of writing data to a file and reading data from a file. Loops are usually involved in programs that process a large amount of data stored in a file. For example, let's say that your instructor wants you to design a program that will create a file containing all of the integer numbers from 1 up through 1,000. Here's an example of what the file might look like after it's been created by the program. You see it starts with the number 1 and it contains all of the integers from 1 up through 1,000. Well, how would you design a program that would create a file like this? Well, when the program runs, first it's going to open this file, and then it's going to write the number 1, then it will write the number 2, and so forth, all the way up through 1,000. But obviously the program wouldn't have 1,000 write statements. Instead, it would have a loop that iterates 1,000 times, and inside that loop there would be one write statement. Here's an example of what the program might look like in pseudocode. First, we declare an integer variable named number. We're going to use that variable to hold each one of the numbers in the sequence of 1 through 1,000. Then we declare the output file, and we're going to refer to it as number file. And then we open the number file, and in this case we're going to open it as a file named numbers.txt. Then we have a loop that iterates 1,000 times for number equal 1 to 1,000. So this loop iterates 1,000 times, and the number variable will be assigned the values 1 through 1,000 as the loop iterates. Inside the loop we have a write statement that writes the value of the number variable to the number file. And then after the loop has finished, we close number file. Here's the flowchart for the program. First we make our declarations. We declare the number variable and we declare the number file. Then we open the number file, and then we enter the loop. First we set number equal to 1, and if number is less than or equal to 1,000, then the loop iterates. Inside the loop we write the number variable to number file, and then we increment the number variable, and the loop starts over. So this loop will iterate 1,000 times, and then when it's finished we close number file, and that's the end of the program. Now this program represents the typical pattern that most programs have when they use a loop to write a large amount of data to a file. First they open the file, then they have a loop that during each iteration it writes a piece of data to the file, and then when the loop is finished it closes the file. Now when we want to read a large number of data from a file using a loop, the process is just as straightforward as long as we know exactly how many pieces of data are in the file. For example, the file that was created by the previous program contains exactly 1,000 pieces of data. So we could put together a program like this to read all of the data in the file. Here we're going to declare our number variable, and then we're going to declare another integer named count, and then we declare an input file called number file. So next we open number file, and then we have a for loop that iterates 1,000 times for count equal 1 to 1,000. Inside the loop we read a value from number file, and we store it in the number variable, and then we display the number variable on the screen. So this for loop will read 1,000 values from the number file, and it will display those values on the screen, and then we close number file. Well, this algorithm works fine as long as the file contains at least 1,000 pieces of data. What if the file contains an unknown amount of data? What if we simply don't know how many numbers are stored in the file? Well, let's say that the file contains not 1,000 pieces of data, but let's say it contains 984 pieces of data. If we try to run this algorithm, which reads 1,000 pieces of data from the file, an error is going to occur because we simply can't read beyond the end of the file. So most programming languages provide a mechanism for determining when you have reached the end of a file while you're reading it. In your textbook we use a function named EOF to make this determination. EOF stands for end of file, and it works like this. We pass an internal file name as an argument to the function, and if we have reached the end of that file, the function returns true. Otherwise, the function returns false. Now, this function is similar to functions that exist in several programming languages, and this can be used in a loop that is set up to read data from a file until we reach the end of the file. Here's an example. In this program we've declared an integer variable, number, and we declare an input file, number file, and then we open the number file. And then we have a loop that reads data from the file. Notice that this is a while loop, it says while not EOF number file. So basically this loop will iterate as long as we are not at the end of the number file. During each iteration, we read a value from number file and we store it in the number variable, and then we display the number variable on the screen. So the loop will stop executing as soon as we reach the end of number file, and then we close number file. Here's the flowchart for the program. First we declare the number variable, then we declare number file, and then we open number file. And then we enter the structure for the while loop. So the while loop will execute as long as this expression is true, not EOF number file. If that's true, we read a value from number file and store it in the number variable, and then we display the number variable on the screen, and then the loop starts over. So as long as we are not at the end of number file, this loop will continue. When we've reached the end of number file, then the loop will stop, and then we close the file, and that's the end of the program.
So as you can see there, we can basically loop through the different records, whether we write to them, whether we read from them, and we don't have to know how many records are there. We can actually utilize the end of file marker to basically let us know when we've reached the end. Okay, so here we have declare integer num days, declare integer counter, declare real sales, and then we declare output file sales file. So since it's output, that means that's all we can do is write to it, and if anything's there, it's going to be wiped out first time we open it. I display how many number of days do you have sales, and then we input num days, and then I open the sales file, double quote sales.dat. So I have integer num days, integer counter, sales, which basically can contain decimal places, and I've got num days, or I've input, and I have data in num days, and I've opened a file called sales file. Then I say for counter equals 1 to num days, display enter the sales for day $, or I'm sorry, £, counter. Okay, so it will basically tell us, it will display into the sales for day 1, day 2, day 3, day 4, day 5, depending on how number of days we entered there in the beginning. And then we go ahead and, so whatever we enter, it will write the sales file sales. What is sales? It's a decimal place numeric value, and that will be written as one record. Then I close the file, and then I display data written to sales.dat. Okay, so it would say enter the sales for day 1, we entered 1,000, enter sales for day 2, we enter 2,000, day 3, 3,000, day 4, 4,000, day 5, 5,000, data written to the sales.dat. Okay, so so again, I would have 1,000 in my delimiter, 2,000 delimiter, boom, boom, so on and so forth. And at the end, I have my EOF that basically lets know where the file basically ends. Okay, so I have my, so in a flow chart, it would look like this. Start, declare integer num days, declare integer counter, declare real sales, declare output file, sales file. Display for how many days do you want to have sales. I input those that integer data into num days. And then I open sales file sales.dat. Then here is my loop. I set my counter equal to 1. If counter is less than or equal to num days, if that's true, I'm going to basically keep looping through. When that becomes false, I'm going to get out and close the sales file, display sales or data was written to sales.dat and end. Inside the loop, I display enter the sales for day £, and then the counter will display the counter number. I input that as one record sales, that I write to that sales file, that sales record, and then I set the increase the counter by 1. Okay, so as we saw in the video example, instead of basically having a counter in this case, how about when we write to a file, we basically write until we have no more records. And once we close that file, an end of file marker is then set at the end of the file. Now I'm going to read a file as opposed to basically going through the number of counters, because I don't know what that counter is. I'm going to instead read till the end of file. So I declare input file sales data, so now it's an input file. I declare real sales. I open the sales file, sales.dat, and I display here are the sales amounts. Now, while not EOF parentheses sales file, so I have to tell it what end of file marker I'm looking at. I'm looking for the end of file marker within sales data, the object sales data, not the sales.dat, but the actual variable, the file variable sales file. So I read sales file. So when I read sales file, so I'm reading that file, one record, and I'm throwing that into the sales variable. I then display the current, I'm displaying currency format sales. Okay, it's going to put a $sign and 2 decimal places. We basically loop back around. Have we hit the end of file? No, we haven't, because I'm pointing at the next record. I can see the next record. I read it, display it, come back around. Do I see end of file? Nope, I still see another record, so I basically read it, display it, come back around. Do I see the EOF? Yes, I do. I basically drop out of the while loop, I close the sales file, and that is basically it. This is what it looked like as a flow chart. I start, declare input file sales file, declare real sales, open sales file, that sales.dat. Then I display here are these sales amounts, not EOF sales file. So if that's true, if it's not, then we're going to basically read the sales file, display the currency format, come back around. Keep doing that until we've reached the EOF. Once we've done that, we close the file and we basically end out. Okay, so here's one end of the spotlight that we're going to go through. So Kevin is a freelance video producer who makes TV commercials for local businesses. When he makes a commercial, he usually films several short videos. Later, he puts these short videos together to make a final commercial. He's asked you to design the following 2 programs. A program that allows him to enter the running time in seconds for each video short video in a project. The running times are saved to a file. A program that reads, so the second program is going to read the contents of that file, display the running times, and then display the total running time of all these segments. Okay. So here's the algorithm we need to do. We need to get the number of videos in the project, open an output file. For each video of the project, we're going to get the running time. We're going to write that running time to the file. We're going to close the file. So pretty simple. We declare the output file video file. We declare integer num videos. We declare real running time. We declare the integer counter. We display enter the number of videos in the project. We input num videos. Output video file video times.dat. For counter equals 1 to num videos. We display enter the running time for video and the counter. We're going to basically loop through that, and we're going to write that running time to the file. That's one record that's going to be written. Once I'm done with that loop, depending on how many videos we're basically processing here, we're going to close the file. We display the times have been saved to video times.dat. Okay. There is the for loop. You can look at that at your leisure. Now the next one is we need to initialize the accumulator to 0. Open the input file. While not at the end of file, read a value from the file, add the value to the accumulator, close the file. Display the contents of the accumulator as the running total time. So I declare input file, video file. Now I'm inputting it. Declare real running time. So this is a decimal numeric value. Declare real total, and we're initializing it to 0 because we're going to be adding to it. We open the video file, video times.dat. We then display, here are the running times in seconds of each video in this project. While not EOF video file. So while that statement is true, while we're not at the end of file, we're going to then read the video file and we're going to input that record into running time. Now we're assuming that one record is one field, and we're going to throw that in there. We display the running time. Then we set total equals total plus the running time. So we're going to add whatever we read into the total. We close that file when we're done, and we're going to display the total running time of the video is total seconds. Okay, so in this case, if it was 24.5, 12.2, 14.6, so again, it's reading each. So again, back here we inputted 24.5, 12.2, 14.6, 20.4. Okay, so we inputted those. Now we're reading the record, we output each one, and then we basically say the total running time of the video is 113.5. Again, you can look at that particular flow chart at your leisure. Okay, so looping, we can loop while we read, or I'm sorry, we can loop while we read a file, and we're looking for the end of file marker. Okay, so this next section, so we've covered arrays. How can we use arrays and files together? So it says for some algorithms, files and arrays can be used together effectively. You can easily write a loop that saves contents of an array to a file. So we can load an array, and once we've loaded that array, now we can basically write to a file. So I can have constant integer size equals 5. Declare integer numbers size, so this array is going to have 5 elements, 10, 20, 30, 40, 50. Then I basically declare integer index, declare output file, num file, open num file values.dat. For index equals 0 to size minus 1. If you remember from arrays, we always have to start with 0. And I can't go, in this case, if there's 5, I can't go from 0 to 5 because that's 6. I have to go 0 to 4 because 0, 1, 2, 3, 4. Okay, that's 5. So I write num file numbers index. So whatever's in that numeric value, I'm going to, for that element, I'm going to write that to the file. I'm going to do that 5 different times. When I get done, I close that file. And then I can say constant integer size equals 5, declare integer number size, and now I can declare integer index equals 0, declare input file this time. Now I'm going to input it, and I'm going to input the file num file, open number file values.dat, while index less than or equal to size minus 1. Okay, again, as we know about arrays, we start at 0, so if it's got 5, we're going to end at 4. And not EOF. So in this particular case, we know the size, and we know there's also an EOF. So we're going to basically have kind of a catch here. So in case our array is larger than the file size. So write number file I don't think we can do this, can we? Write number file. We opened it for input. We're trying to do a write now. We can't do that. Ooh. I'm going to have to contact the publisher on this one. Okay, so anyways, that should be a read there. So we're going to read the number file, and we're going to load it into the index. Okay. Yeah, that's crazy. I'll have to get a hold of them on that one. Okay. Okay, so up to this point, you've seen that we are assuming that each record is one field. What if we have multiple fields per record, which is what 99.9% of every record out there has multiple fields in it. So in this particular case, we have a record that has a name field, an ID number, and a department field. Okay, that's one record. It's got 3 fields. I want you to think of an employee record. So if you had to write an employee program, you're going to have first name, last name, probably middle initial, at least middle initial, street address, city, state, zip, number of dependents, all of the personal information that you can basically think of as far as what is in an employee file. I mean, there's all kinds of tax data and income and pay rate and all that stuff is there that we'd have to have inside of that. So there's a whole ton of fields you would have. So I want to write a record that has multiple fields. So I would say write employee file name, ID number, department. So notice I've got name, comma, ID number, comma, department. That is considered one record. It has 3 fields. Each one of those is a variable. So here I have declare string name, declare integer ID number, declare string department. So I've got my 3 variables. I then declare integer num employees. I then declare integer counter, declare output file employee file. So this is an output file. I can only write to it. I display how many employee records do you want to create. Then I input the number of employees. Then I open the employee file employee.dat, and then I have my for loop. Now this is a pretty good size for loop, but I'm going to go from counter to 1. So the for counter equals 1 to num employees. I display enter the name of employee # counter, which first time through would be counter or employee #1, employee #2, so on and so forth. So I input the name. Display enter the employee's ID number, input ID number. Display enter the employee's department, input department. So now I have those 3 variables filled with data. Then I'm going to say write employee file name, ID number, department. That's one record that has 3 fields. Then I click display. Now why did I do a display? So there's a blank line, so the next time I basically display enter the employee's ID number, or I'm sorry, employee's name, it will basically have a blank there. It comes back around, it's going to do that for how many times you entered the number of employees, and once we get done with that loop, we close the employee file and we display employee records have been written to employees.dat. So in this case, I might, I got 3 employees. I type in Colleen 7311, accounting, Ryan 8996 is in security, and Bonnie Dundee, ID number 2301, she's in marketing. Okay. So this is what the file would look like. I've got a name record, I got a name field, an ID field, and a department, and each row is a record. So the first row has Colleen Pickett, ID number, accounting, and there's the next 3. Okay. So here's what we have. I don't like this example here because it's got Colleen Pickett, then a delimiter, which is usually a comma. That's usually the most common is a comma. And then 7311, delimiter, accounting, and then delimiter. That delimiter is really a next row or next record delimiter. These delimiter are field delimiters. This one is actually a record delimiter. And I wish they would kind of differentiate those within this example. And that's kind of what they're saying here. When records are created in a file, some systems write one type of delimiter after each field and another delimiter after each record. So now we're going to read each record so it has different fields. So here I declare string name, declare integer ID number, declare string department. Declare input file employee file, and then I open employee file double quote employee.dat. Then I display here are the employee records. While not EOF employee file, so while it's not the end of file, we're going to read employee file, and the fields are name, ID number, and department. So it's going to read that record, and it knows that it's going to grab a field, look for a delimiter, grab the next field, look for a delimiter, and grab the next field, and it's going to throw those into each one of those different fields. Then I display name colon comma name, display ID number colon ID number, display department colon department. And then we have, again, we want to throw a display in there just so that we have a blank line, so when it displays down below here, we have this blank line between each employee. Again, once we get done, we always need to make sure we close that file. It says here, if you're a programmer for a company or an organization, you will most likely have to write programs that read data from files that already exist. The files will probably be stored on the company's servers or on some type of computer that is part of the company's information system. When this is the case, you will not know the data is organized with it. You won't know how the data is organized. For that reason, companies and organizations usually have file specification documents for each data file. A file specification document describes the fields that are stored in a particular file. So again, as a programmer, I have to know how this file is laid out. And so we'll have this file specification document that allows us to know when I'm going to read that file, when I'm going to write to that file, how am I going to process it? Okay, how are the delimiters set up, how are the end of file set up, all that type of thing. Okay. So here's what it might look like. We have file name employees.dat, description, each record contains data about employee. Field description is the employee name, ID number, and department. The data type for each one of those is string, integer, and string. Okay. So I want you to go through this in the Spotlight, adding and displaying records. Basically, Midnight Coffee Roasters Inc. is a small company that imports raw coffee beans from around the world and roasts them to create a variety of gourmet coffees. Julie, the owner of the company, has asked you to design a series of programs that she can use to manage her inventory. After speaking with her, you have determined the file needed to keep the inventory records. Each record should have two fields holding the following data: description, which is a string containing the name of the coffee; quantity and inventory, the number of pounds in inventory as the number. So again, go through that to get a good feel on how to basically write to the file. Again, here is, they give you the pseudocode, they give you the flow chart. And the next job is to design a program that displays all the records in inventory. So now you're going to read that file and basically display it. Okay. So again, go through that. So now we need to modify those records. So Julie's happy with the program. Your next job is to design a program that she can use to modify the quantity of the field in an existing record. Okay, so go through this one. So now we're going to read a record, and we have to basically modify it. So So what we're doing here is we're declaring an input file. Let's just go through this. Okay. So here I declare string description, declare real quantity. So again, we've already got a file that's got data in it, and I need to update the quantity. So declare string search value, declare real new quantity, declare Boolean found if, and then we're going to set that to false. We're going to assume it's not found yet. And we're going to declare input file coffee file, declare output file temp file. Okay, we'll see what we're going to do there. Display into the coffee you wish to update and input search value. So we're going to type in the coffee name that we basically have. And then we're going to display into the new quantity. We're going to input the new quantity. So while not EOF coffee file, we're going to read the coffee file, and we're going to read that record into two fields, description and quantity. We're going to say if description is equal to that search value, we're going to write to the temp file the description and new quantity. We're going to set found equals true. Else we're going to write to the temp file the description quantity. So no matter what we do, we're going to read from the coffee record, and if we did not find the search value we're looking for, we're going to go ahead and write that record to the temp file. We're going to read the next record. If not found, we're going to write that record to the temp file. We're going to read the next record. If we did find it, we're going to go ahead and write the description. We're going to update the quantity. We're going to set found equals true, and we're going to keep doing that until we basically go through the entire file. So when we get done, we're going to have two files. We've got our existing coffee file. We've got our new temp file. They're going to be identical except for that one coffee that needed the quantity updated. That quantity will now be updated. So we're going to close the coffee file. We're going to close the temp file. We are now going to delete coffee.dat. We are going to rename temp.dat to coffee.dat. So you see what we did there? We have our coffee file. We have our new temp file. We go ahead and delete the coffee file. It's gone. We take the temp file. We now rename it as the coffee file. Boom. Now we've got a new file that has all the quantities updated. Now, the one thing that I don't see them doing here is the found. They don't do anything with the found. Okay? Is down here, I would have had an if statement that said, if found, basically delete the coffee file and rename the temp file. If it wasn't found, there's no need to do that. Okay, we can just go ahead and delete the temp file at that point. Okay, you can go through that flow chart on your own as well. Here's in the Spotlight deleting records. So we want to be able to delete a record. Same exact process, except here's what we're going to do. We are going to have our inputs. So we got our coffee file, we got our temp file. What we're going to do is we're going to read a record from the coffee file. If that file is not being deleted, we're going to write it to the temp file. We read the next coffee file record. If that doesn't need to be deleted, it's going to be written to the temp file. If we read the next record, if that needs to be deleted, we're not going to do anything. We're just going to read the next record. We're going to keep reading records and only write the records to the temp file that are not being deleted. And again, we wipe out the coffee file, we rename the temp file to the coffee file, we now have that file updated and it doesn't contain the records that need to be deleted. Okay. Now this last section is this thing called control break logic. Now control break logic relies on quite a few things kind of happening so that we can basically do this. So for example, I want to show in this example here, I've got data. I have a store number, which is an integer. I have the state within that where that store number resides, and then I have sales for that store. Now what I want to do is I want to show totals by state. So the very first thing I have to make sure that I do, so again, this is a file and each one of these is a field. So this is a field, this is a field, this is a field. Okay, store number, state, and sales. The very first thing I have to do is I have to make sure that my records are sorted by state. That's the most important thing that I have to basically stress here. They have to be sorted by state. Because here's what I'm going to do is I'm going to put this into a loop and I'm going to basically drop out of that loop to basically go to a new state. And that's where the control break means. So I'm going to loop, loop, loop until I go to a new state. That's the break. I then have to come back around and start that loop over again and basically total by state. Okay? So this is what the report should look like. Store number, state, sales. Here's the three particular files within that state. I show the total for that state, total for that state, total for that state. So how it works is this way. So here's the main module. So again, so now we've modularized this. We're going to either have modules or functions or both. So I've got my module main. I call print header. Notice, again, I always know it's a module because it's got parentheses. I know it, and I'm not receiving anything back, so I know it's a module. So I'm calling print header, then I call print details, and then I end that module. So here's my print header. It prints Pine Brook Academy fundraising report. Print a blank line, then print student ID, space, 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 donation amount. Then I print bunch of equal signs. That's going to be my underline and least across my column headings, and then I end. When I come back and click print details, here's how it works. So here's my module, print details. I declare integer student ID, declare real donation, declare real student total equals 0, declare real total equals 0. So I've got two totals. I've got a total by student and I've got a total by a grand total. Okay, so I declare integer current ID, declare input file donation file, open donation file donations.dat. So I'm assuming that we've got a file out there called donations.dat and it contains data. I then read the donation file, student ID, and donation. So one record contains a student ID, a delimiter, and then a donation. Then I set the current ID equals student ID. So this is where we have to set up our control break. So what I've got inside of my file, I've got a bunch of students who've collected different donations. So student 1 may have 5 records in there where that student has collected 5 different donations. Student 2 may have only collected 3. So I've got student 1, student 2, student 3, so on and so forth. Now again, the very first thing I should have done before I got to this point is I should have sorted it by student ID. That is a basically prerequisite for any control break programming. So the very first thing I do in a control break program is I set my current ID, so my current field, equal to the very first field of the very first record. Okay, so that's why I read this first record. Then I come in and I say while not EOF donations file. So while I'm not at the end of file, I'm going to keep doing this. So if student ID is not equal to current ID, now notice I've got student ID. I'm making the assumption I've already read a record. Okay, I'm making that assumption, which we already have, right? We've already read the record because remember I had to read the record right here so that I could set the current ID field. So if student ID is not equal to current ID, well, it is. I mean, that statement is false right off the bat because remember I've already read a record, I've set that to that. So I come down here to end if and I print student ID tab currency format donation. Set student total equals student total plus donation. Set total equals total plus donation. Okay? Then I read the next record. So I'm doing the read at the bottom of my while loop. I come back up here. Now, if I've read 5 records from student 1, and now I just read the first record of student 2, so student ID does not equal the current ID because the current ID is 2 and the current ID is 1. So now I've got a new student and I want to show the total for that student. So what I do is I say print total donations for student, currency format, student total. Okay? And I then do a print blank line. Now I have to now set up my control break to basically process the next student. To do that, I set the current ID equal to the student ID. So now I'm at student 2. The current ID is now set to student 2. And then I set the student total to 0 because I need to clear out the student 1 because I'm now totaling for student 2. When I drop out of the if statement, I go ahead and print the student ID, a tab, currency format donation. I then set the student total equals student total plus donation. Remember, student total got set to 0 up here. So now I'm on student 2. I'm adding students 2 total to the student total. I've already printed student 1's total. Now I'm dealing with student 2. Notice that total is not reset. That's my grand total. I'm adding to that thing. I'm adding for every student. I read donation, student ID and donation. Come back around. Next record is still student 2, so basically I do not go into the if statement. I come down here, I print their data. I go ahead and add that donation to the student's total. I then add the donation total to the grand total, and I read the next record. Come back around, now I'm on student 3. Now I need to go back in this if statement, display the totals for student 2, reset my current ID to the new student 3 ID, and I reset the student total to 0. So now when I come outside of that if statement, I'm now processing student 3, student 3, student 3, now it's student 4, so I have to print student 3's totals, reset the current ID to student 4, then come in and process student 4, student 4, student 4, student 4. Now I'm on student 5. I go in, I print all of student 4's totals. I reset the current ID to student 5. Okay. Then when I get to the very end and I get outside the loops, I've hit my end of file. Now I print total donations for the student. So again, now here's the thing. When I hit the end of file, guess what I've not done? I've not done anything inside of this if statement for the current student. So I have to take care of the totaling for that student. So I do that here. I print total donations for student, currency format, student total. And then I print the total of all donations, currency format, total. Okay, so notice this I am doing for the very last student, because since I hit the end of file, I didn't get a print what was inside this if statement. So I have to process the last student, their total, then I can print the grand total, and then I go ahead and again make sure that I close the file. Okay, there's a flow chart for that as well. Printer spacing charts, these are actually big charts that they usually go 133 characters wide, but what's nice about them is what you will see is these first 2 rows will be printed and this first column will be printed. And what we do as programmers is we go in or we would probably work with our business partners to design a report. And that's basically all this is doing. This is allowing us to design a report. So so the first 3 spaces are going to be blank, and then 4 through 12 is going to have Pine Brook, 13 is going to have a space, and then Academy. So again, we can lay this thing out character by character by character. Now the problem with this, the good and the bad of this is this. We have monospaced fonts and we then have non-monospaced fonts. Monospaced fonts means a lowercase I and a W take up the same amount of space. In a non-monospaced, which is called proportional, a W takes up really wide, whereas lowercase I takes up a tiny little space. So this won't really help in that particular situation. Where this really is used a lot, a printer spacing chart, is in mainframe programming, because reports that come out of mainframe programming are they're always most likely monospaced reports. So, but anyways, so this printing spacing chart allows us to now design a report on how many spaces and commas. Now again, the one thing you have to always take into consideration when dealing with numeric values is commas and decimal places. Okay, so okay, that's it for the chapter. Again, any questions you may have, go ahead and send me an email and I can get those answered for you.